All right, we are doing inverse of functions. What do you, does anything come to mind when you hear the word inverse?
Opposite.
Opposite. Yeah, beautiful. Opposite. So like the inverse of multiply is divide, right? The inverse of add is subtract. What do you, when it comes to graphs and functions, what do you think the inverse of a point is going to be? If they start out at xy, what's the inverse? Yx. Yeah. Okay. The signs do not change. They just literally switch spots. Okay. For a function to be a one-to-one correspondence, okay, so it to be considered an actual, so let me back up. When you have a bunch of ordered pairs, it's a relation, okay? But if only each input has its own unique output, it's called a function, okay? Which means your y values cannot repeat. I lied. Your x values cannot repeat. I'm getting confused, guys. If we had some points, let me do this. This is going to help us. If I have an xy graph, and I have the points, let's say 3, 4, 5, and it goes 7, 8, 7, this is a function. Okay? But if they were flip-flopped, if it went 7, 8, 7, and then 3, 4, 5, like that, this is now not a function. Okay? Because your x's cannot repeat. So look at the table we have here. We have an input and we have an output. Is this considered to be a one-to-one correspondence or a function? Every single input value corresponds to exactly one output value. So is it a function? Yes, this is a function. Okay. Notice that every output value corresponds to exactly one input. So when nothing repeats at all, this is called a one-to-one. Okay. So when nothing repeats, every x has its own unique y, it's going to be a complete one-to-one function. Okay, so we have relation, just a whole bunch of points. We have a function, which is where my x's do not repeat. And then we have one-to-one, where I don't have any x's or y's repeating themselves. Okay, so look at these two examples, f and g. Are they one-to-one? So look at my first one. We have negative 1, 6, 0, 5, 3, 2, 7, 10. Is this a one-to-one function? Yes. How about negative 5, 4, 2, 6, 3, 5, 10, 4? No, it's not one-to-one. Is it a function? Yes. I have unique x's, but it is not one-to-one. So it is a function, but it is not one-to-one. If I have an actual graph, we can use a vertical line test to determine if it's going to be a function or not. Okay, meaning I would draw a vertical line and see, does it cross over it more than once? If it does, it fails. Okay, what type of line test could we use to see if it's one-to-one? Horizontal, yeah. Vertical lines, whoops, come back, where is it? Vertical lines test if we repeat any x values. Y values, y'all, I'm losing it today. I'm losing it. Horizontal line test is going to see if we repeat any x values. Okay, so look, if I had a parabola, I would use a horizontal to see if we have anything repeating. So would a parabola, I'm kind of skipping ahead, would this pass, these both pass the vertical line test, okay? Does this first one pass a horizontal line test? Yes, so this one is going to be one-to-one. Do parabolas pass horizontal line tests? No. Do they pass the vertical line test? Yes, so parabolas or quadratics, they are functions. We've been working with them, but they're not going to be one-to-one. All right, so why are we talking about one-to-one? Well, because every one-to-one function, you can find the inverse of it. Okay, there's an inverse function. The output of the original function becomes the input of the inverse function. Okay. The symbol, this is called F inverse. This is how you say that out loud. F inverse is used to denote the inverse of the function. Okay, so we usually write it as F inverse of X or G inverse of X. That's usually how we write it. Okay, so I told you, if we think inverse is opposite, how do you think we find the inverse of a point? Instead of xy, it becomes yx. So here, to find the inverse of f, instead of -1, 3, it is now 3, -1. Instead of 0, 4, it is 4, 0. Instead of 2, -6, it is now -6, 2. Instead of 3, 6, it is now 6, 3. Instead of 7, -8, it is now -8, 7. Like that. Okay. So if you're given a bunch of points, you literally just flip-flop them. Now, what if I'm given a function? Okay. I need to switch my x and my y. But if I have f of x equals 5x plus 2, I don't see a y. But what is my y? The f of x. So this is the same thing as saying y equals 5x plus 2. So to find inverse, change f of x to be y. Now I can switch x and y. Here comes the inverse part. So I'm going to flip-flop them. So now we're going to have x equals 5y plus 2. And we're going to rearrange to solve for y using all the inverse operations, and that's how we get the inverse function. So in this case, I'm going to subtract 2 and then divide by 5. And that becomes the inverse function, because we use all of my inverse operations to rearrange the equation. So change f of x to be y equals, switch your x and y, and then solve for y, which is now your inverse function. What do you think we're going to do on an actual graph? Think we can just flip them? Yes, no, maybe? There's a couple of ways to do it. So we're going to do 5x plus 2, which is what we just did algebraically. So I know that my inverse function, I'm going to write it as 1/5 x minus 2 over 5, just to help me graph it here in a minute. How do I graph my original? Start at 0, 2, good, and then do what? 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Kind of goes off. 1, 2, 3, 4, 5 backwards 1. 1, 2. Oh, hold on. I can't do this. 1, 2, 3, 4, 5 backwards 1. All right, so here is my original. This is f. All right, we can plot points. We can switch x and y values. We have some options here. Because to have a y-intercept of -2/5, that's kind of hard to graph, right? What is 2 divided by 5? The 0.4, I think. So it's a little bit harder to graph when it's not a whole number. But that's okay, because I can take my points and I can switch their x, y values. This was the 0.02. So what's going to be the inverse of that? 2, 0. This looks like the point, what is that, 1, 7? So what's the inverse of that? 7, 1. What is this guy? -1, -3, right? So I can make it -3, -1. And the one at the bottom, that looks like negative, that's -3, -1. This point looks like -2, -8. So I'm going to make it -8, -2. And this is our inverse function. Okay. So look at the one we just did. Look at the example they have for you over here. They have the original function, it's a cubic function, and then my inverse is actually a cube root function. Okay. What do you notice about what's happening between our graphs? We know we're switching x and y, right? That's literally what we just did. We know we're switching x and y. Anything else you notice? It's what? It's rotating? Kind of. You're on the right track. There is a symmetry going on. There's a reflection happening. There's a reflection happening over y equals x, which is the diagonal. If I folded my paper across the diagonal of y equals x, it is symmetric, which makes sense, right? We're switching the x's and the y's. Y equals x, they're switching. If I took that and I reflected it over the diagonal, you would get this inverse function on this side. You okay about inverses? How do we feel about it? Okay? Y'all gotta talk to me. Confused? You're allowed to be. All right, consider the following graph of f of x. So they've given me my original. They want you to graph the inverse. Okay? So what do you need from the original? We need points. Yeah. So make yourself a little table. Make a table of values, and then how can you use those to make your inverse? Switch them. So do it. I'm going to pause. You're going to keep going. All right. How did you do? Good? Anyone know what kind of function that first one is? Bonus question. 0, 0, 1, 1, 2, 4, 3, 9. This is, yeah, that's coming from x squared. So what do you think, and what's the inverse of square? If you square something, square root. Is that what the inverse function is? 4, 2, 9, 3, yeah. So this is the square root of x. This guy was x squared. All right, we good? All right, the next two are on you. You're going to determine whether each function is 1-to-1, okay? If it is, I want you to write the function. So you should say yes or no. If you say yes, then actually tell me what the inverse is going to be. All right, so you are doing H and S. Is it a 1-to-1 function? If yes, write the inverse. If no, just say no, it's not. All right, did you say yes or no for H? No? Yes? Yes. Ooh. My X's are 11, 4, 3, 8. No repeats. My Y's are 13, 3, 4, 8. No repeats amongst the Y's. So when we do the inverse of it, what's my first point going to be? 13, 11. There you go. My next one. All right, next. And then lastly, 8, 8. Okay, don't let the double 8 on the end confuse you. One of them is an X and one of them is a Y. So all you care about is do the X's repeat. So in my set of X's, you have 11, 4, 3, 8. And then the other one is part of your set of y's, 13, 3, 4, 8. Okay, so don't get confused about that. All right, S, is it 1 to 1? No, it is not. What repeats? My y value of 5 repeats itself. So it is a function, but it's not a 1-to-1 function. All right. I'm going to put still a function. Still a function, just not a 1-to-1. All right, beautifuls, you want to try to find the inverse of functions on your own? Still need me? Yes? Okay. First thing, what am I supposed to do? Instead of f of x equal, make it y equals. Y equals x over 4 divided by 7. Now what do we do? Switch the x and the y. Yes. So now it's going to be x equals y minus 4 over 7. We got to do all of my inverse operations to get my inverse function. How am I going to move what piece? Sub with the 7. What am I going to do with it? Multiply with the 7. Yeah, multiply both sides of 7. So now I have 7x equals y minus 4. Now what? Add that 4 over. Does that become 11x? No, they are not like terms. Keep them separated. I got y by itself, so now we have our inverse function. So our inverse of f is going to be 7x plus 4. Look at my original. I was dividing by 7, right? My inverse, I'm multiplying by 7. In my original, I'm subtracting 4. In my inverse, I'm adding 4. Right? So all of our inverse operations got used. All right, let's try G. The cube root of x plus 1. All right, before you do anything, what has to be done first? There you go. Change g of x to y. So y equals the cube root of x plus 1. All right, now what? Change that to x equals, good, cube root of y plus 1. All right. It's a giant 3. Looks like I'm multiplying from it. I'm not. Cube root. Okay, what do we do? Cube both sides. Yes, to get rid of a cube root, you cube. So now we have x cubed on this side, but we're left with just a y plus 1. Now what? Subtract 1. Whoa. Sorry, guys. So we have x cubed minus 1 is equal to y. So we're done, and now we have our inverse function. So g inverse of x is x cubed minus 1. Our original had cube root. My inverse has a cube. My original had a plus 1. My inverse has a minus 1. Do you see how they're related to each other? Yeah, if I still had a plus 1, I should be like, oh, I messed up. That shouldn't still be a plus 1. That shouldn't still be a multiply. Okay? You should have the inverse of everything that you started off with. Questions about points, a list of ordered pairs. Questions about finding the inverse of a function. Okay, so now we're going to go into graphs. Both of these have the original graphed for you. It wants you to graph the inverse on the same coordinate plane. All right, I like to make t-tables. That's what I would suggest for you to do as well. So I'm going to pause. You keep going. All right, check yours with mine. It's always a good idea to label what is your original and what is your inverse. How'd we do? When I walked around, I saw good things. Hopefully this is a nice, chill lesson. You probably did some of this in Algebra 1 also. I know I taught it a couple years ago in Algebra 1. Okay. The reason why this is important is because later we're going to deal with exponential and logarithmic functions, which are very fun. And we need to understand inverses when we get there. So, all right, for the rest of today, work on your assignment that you got from the table. If you get it done, I will stamp it. And then we will check answers on it tomorrow, and we will start reviewing tomorrow for your test, which is on Friday.